Cool. Hello, everyone. Welcome to weekly SIG Autoscaling meeting for Monday, 5th of May, 2025. We do have a few items on the agenda.
Hello.
New fight.
Yeah, I managed to join. I don't know. It was.
Do you want to take away with your agenda item?
Yes. So, let me know which screen you guys can see. Actually, okay, that's not the one that I wanted. Okay. Okay.
Yeah, can see the autoscaler repo.
Okay. So, maybe I'll start with the. It's basically same. It's the same proposal that I opened in cluster autoscaler repo, and overall the idea is like currently when cluster autoscaler skills a node, it doesn't take into account skills. The cluster doesn't take into account how many volumes can be attached to a node. And specifically to handle this problem in Kubernetes, actually, what we did was even when a CSI driver like is not reporting like if it is installed on the node, we still allow scheduler to schedule pods on a node. So we want to plug that hole basically where we want to prevent scheduling of pods to a node which does not have CSI driver installed. So this so first of all is this PR kind of like fixes that issue, but that this will prevent the scheduling of pods to a node that doesn't have CSI driver installed. We did this to allow originally we didn't do this to allow clusters autoscaler, because when it scales a node and it has no awareness of CSI node limits, when it will scale a node and it will use the scheduler code to try and schedule a node, it will find that like any pod that uses the volume, it will find that the pod cannot be scheduled on the node, so it will keep spinning new nodes and that will go forever. So that's why we did not do this change in the first place in Kubernetes main repository in the scheduler. Now we want to fix this, but to fix this, first we must fix scheduler cluster autoscaler actually, so that it can consider the, let me know font size or anything is small, so it can consider the attached limits available on a node when it scales the cluster. So this proposal has two parts. One is that scaling from one or scaling from zero when a node group doesn't have one or more nodes. And some of this information may be like a little bit out of whack. I apologize for that. I generally work in SIG storage, so I'm not super like intimately familiar with the cluster autoscaler code, but but I've been trying to read it up and everything. So when scaling from one, when the first thing that we need to do is we need to enhance this type in node info struct that is present with what CSI driver will be with the map of CSI driver, the driver name and the allocatable, how many volumes of that type will be available on that node actually. So this is the information that we want to enhance node info with, which will be considered by cluster autoscaler when it schedules pods to a node. But Also, another problem is that when it creates a node, the cluster autoscaler, it needs to generally wait for the CSI driver to be available on the node before it can consider that like node as ready. So originally when I spoke with Michael, I thought that we'll use the same mechanism as GPU label, so that like similarly like the uh, each node that comes up, there will be code in cluster autoscaler, either in the cluster API for cluster API type, or all the cloud provider types that participate in this mechanism. Not all cloud providers will support this mechanism. Not all CSI drivers have this limits, by the way. For example, on AWS, only EBS has this limit. EFS doesn't have limit, like how many volumes you can attach to it. GCP PD GCP PD has similar thing, like file may not have the limit, but the PD driver does have a limit. So originally we were thinking, when we were talking about this, we thought, okay, we'll add a label similar to GPU label, which will come from the cloud provider, and it will tell us like what CSI driver are supposed to be available on the node. And there's the CSI node object for each node that is created. Kubelet creates a CSI node object. When kubelet reports ready status, then the CSI node object is basically empty. It doesn't have any CSI driver installed on it. Uh, Let me see if I have. So, so those of you who are not familiar with it, so this is the CSI node object. This is how it looks like, and they generally match the node name. So there's a 3 nodes and 3 CSI node object, and this object contains information about what when the kubelet reports ready status, then this driver's field in the CSI node object will be empty. And this field, when the CSI driver is registered and if CSI driver starts and registers itself with kubelet, then this information gets populated, that this driver of type csi.vsphere.com supports 59 allocatable volumes on this node. No more volumes can be attached to this node actually. So the idea that initially when we worked through is like each cloud provider will report what CSI drivers it supports, will be should be considered by autoscaler, and when we create a node, we will wait for this to be populated until we consider the node as ready. This is similar mechanism that we use for GPU label, and it will prevent like creation of additional nodes while we wait for the node to be the driver to be installed. So Mike doesn't particularly like, he wants to go with some general mechanism that could work for all this thing, but I will come to that in a bit. So yeah, already we talked about the node info will populate with the CSI driver that will be has this allocatable property, and then we propose that when we save the cluster state, there's a then we capture and add CSI drive information to all existing nodes. So originally when we populate the node list in the beginning of a static run once function, uh, it just gets node info, and it doesn't, because this information has to be derived from a different object, like the CSI node object that I showed you here. So it has to be kind of augmented, and I saw hooks in the code to augment this information. So we propose that when we saving cluster state, we also populate this field. And yeah, when we do the node info groups in this function, what we return in the node info also has this CSI for scaling in from 1. It's easy, but please yeah, we populate the node info with CSI driver information. And last is like we propose that when we're deciding path that should be considered for scaling nodes in pod list or processor function, this function that decides which pod it should consider, pods that need help or something it's called. So there the hinting simulator code calls like decides whether the node that it has just spun up, it may not be ready, but whether the pod, existing pod, can be scheduled on it. So there we add CSI volume limit as well to consider if this pod can be scheduled on the node. So that's the general gist of it. Yeah, scaling from 1. Scaling from 0 is like uh, uh, we are still kind of like, we need for scaling from 0, we need the template information that gets provided by various cloud providers and including cluster API to tell us like what will be the CSI driver available on it and what will be the limit on it. So like for example, like in case of I'm just using OpenShift cluster API machine set as an example. So it has this information like memory this much and CPU this much. So we'll have to add similar annotation for the CSI volume limit actually, and this will be like converted to yeah, these annotations. So and last but not the least, like so this is an existing problem already, and some Kubernetes vendors, in particularly I see Azure and GC and sorry AWS. What they do is when they start a node, like to work around this problem, basically they add a taint to the node when the new node created, and when the CSI driver starts on that node, then that removes the taint actually. Unfortunately, this code yeah, this is implemented for Azure and AWS, but this code is not part of the standard cloud provider code for these two providers. This is done via some proprietary, I don't know, like code somewhere, but like in CSI driver, you can already see mechanism for doing this, add taint removal feature, so that when the CSI driver starts, it removes this taint from the node. The problem with this is obviously it's not, uh, if we do this as a generic feature, then it will break people. Like it will prevent scheduling of pods until all of the pods that don't require volume add this taint. So it's kind of messy. So I just want to know what SIG Autoscaling thoughts are. Have we? Yeah.
Let me respond with a question. Is my mic okay?
Yeah.
Okay. Let me respond with a question. Have you been following the recent DRA developments, particularly inside Cluster Autoscaler? Because basically all what you're describing is what we had to do for DRA. So first of all, the blueprint is already there. If you just like for DRA, instead of CSI node, there were resource slices, and we had to extend the integration surface with the scheduler to pass these resource slices to the scheduler plugin instead of just the scheduler plugin using live informers, and so not actually counting accurately. So that's one thing. And in particular, well, for some historical context, this is how we should have implemented the integration with volumes initially. And I think the only reason we didn't, and the only reason it looks the way it does right now, was like just for shortcuts. But the proper, what I at least think of a proper solution to this problem in general is what we did for DRA. So like make the CSI nodes like make CA be able to simulate the CSI nodes and control them on that side, and then the scheduler plugin code takes care of everything else. There is some care to like scale from 0 is a separate problem that I'll come back to in a second. The readiness at the beginning is a separate problem that we might have a generic solution for though as part of DRA. like hopefully what we do for DRA to take care of this node readiness in the beginning problem would also cover your case. And as far as scale from 0, I have a cap planned. There is an issue for it also in the somewhere in the autoscaler repo for introducing something like a node info template to the Kubernetes API, like a CRD. And so using that API object, cloud providers could expose what a template node looks like, or CA could do it. But what matters is that we would have way more expression power in there, and we could just have a field for CSI that the cloud provider configures as necessary. And my main point here is, because we are running out of time, that we, or I at least, have sort of thought through everything that you've mentioned here already, because it was just one-to-one identical to the array. Like the array was designed based on volumes, and CSI, I think, is the reason. So I'm happy to collaborate, and I'm happy to extend what we did for DRA to CSI volumes as well, because it's a clear gap. Like they work the same way, and we made things nice, or we're in the process of making things nice for DRA. But CSI and volumes are in the exact same place, and we haven't touched them yet. So this would be closing a very nice gap.
Okay, so this is identical. Like what? So how are we what is the work? Sorry, like any link, anything for work done for this for DRA to
Oh
take
yes,
into?
yes.
No.
I have plenty of links for
Okay.
you to peruse. So I will link them somewhere in the agenda doc, maybe, whatever I
Okay.
find relevant, and we can go from there. You can find me on Slack to discuss details, and I will probably have some bandwidth problems in the coming weeks, but this should I can work on this in the background, and sort of help you get this in the right direction. In particular, all of the implementation details should be easy now, because all of the necessary refactors and stuff have already been done.
Okay. Cool. I'll follow up with you on Slack, and we'll go from there. Anybody has anything else? I know we are running out of time. Sorry.
I guess I don't think the chat gets transcribed across, but yeah, it would be as Jack says in there, it would be good to have it in public. But I know it looks like there's some internal restrictions on how that can be done. So. Cool.
Have a public. Sorry, guys.
A version of this doc that is.
Yeah. This already I opened this proposal, which is basically same as this thing. I opened Google Doc because it was easy for me to show this is the public version of proposal doc actually that I
Okay,
already linked here.
I'll follow up with the links on the issue.
Yeah.
Cool. Sweet.
So, Kuba, do you think do we have like which version of Kubernetes is something we are planning to target? Like, I was planning to get this implemented at least as an alpha feature or something in 134.
Yeah,
I feel
that sounds reasonable. So for DRA support in CA, we had a very rough MVP in 132. We're trying to close the most glaring productionization gaps right now for 133. And the plan is to have a sort of a beta, mostly working but not battle tested yet, version for 134. So that sort of aligns with you slapping a new feature on top of that as an alpha, I think.
okay. All right. Thank you.
Daniel, any updates on the Go 124?
Yeah, I didn't have time to make progress on this one since I added the agenda item. What I was thinking is we introduced this mechanism called cloud provider maintenance requirements, which if I remember correctly, we never used. There is a policy that says we can do them, and we never exercise this policy. I wonder if that would be a good moment to do that, because like when I tried to use Go 1.24, it just didn't work. There's plenty of dependencies on different cloud provider code that is not working as is with all the stricter checks in Go 1.24. So the way I thought about going about this one was if I can, like, would it be in line with the policy and what we want to have if I disabled all the cloud providers that don't work with Go 1.24 and send them requests to like update and enable themselves back, or is it too disruptive and we should do something else?
I think that feels too disruptive for me, and certainly in terms of a timeline. If we're saying we would want to do it for 133.
Because like we like 1.33 is out already. We will be cutting autoscaler once the array changes are in, I guess. Yeah. So that's.
Does that require the bump, Daniel? Does that require bumping to Go 130 to the next?
Yeah. Go? So the KK 1.33 is on Go 1.24.
So is it even feasible given the timelines then, like for the cloud providers to react? And are the changes that would need to be done so involved that we couldn't like bulk do them for the whole repo? Isn't like
so the problem is that the changes are also not only in our code but in some SDK imported by, I don't remember which cloud provider, but it's not just local change.
Fair enough. What are the, like, do we have any time guarantees in that policy? It wasn't like a month.
I don't think we were actually explicit on the policy itself. Okay. But I sort of feel like publishing. Oh yeah. And to be honest, we also didn't follow the. We didn't really follow the policy of like if no CMRs are issued in a given minor release, we'll issue an empty CMR to verify. So I think we should start following that process. Do you have any idea, Dan? I think I can't remember if you were actually on the call last week, but we did discuss it a bit. Do you have an idea of how complicated it might be to try and update the SDKs for the affected underlying like cloud provider implementations?
I did not try to like go and fix other repos because that would require changes to some dependencies first and then importing them to the autoscaler. Jack?
Yeah, Daniel, do you want to try to work together? I'd be happy to take a crack at this. As hard as this sounds, it's a lot easier than going out a tree, which would probably be the right solution. But that'll take 5 years. So I've been there before with Kubernetes.
What approach do you have in mind? Like,
I would say for maybe a week of trying to reach out to the maintainers of the cloud provider projects that are having trouble, and then maybe we just try to do it ourselves.
Okay.
I mean, that's probably what's been done in the past, right? I assume this has happened from time to time, given the the way that the mono
has,
repo is set up. No.
I don't think it has actually. Like Go historically hasn't been so bad about breaking changes. It's getting worse in the recent releases.
Yeah,
Yeah.
it just got stricter about checks. Like the code that was previously compiling happily is no longer.
I mean, that is, yeah, it's really only the Go vet, right? It's not actual.
Yes, yeah, I think so.
Yeah, we could figure it out. If you're up for it, I mean, I can be up for it. I do think we should definitely reach out to the cloud providers to let them touch their own code first. But
I think if it's just Go vet, there should be a way to like opt some checks out until things are fixed.
Oh, that would buy us some time.
Yes,
So maybe that's
potentially that like might be an
Mhm.
option.
Okay, I can try that, and then we'll see how much of a feedback we'll get from all those cloud providers.
Awesome. Thanks.
Okay, thanks.
Cool. In that case, thanks very much, everyone, for your time, and see you all next week.
Thank you.